Hello and welcome to the while loop Energia video tutorial. A while loop is a section of code that will loop as long as the conditional argument is true. While loops are popularly used as forever loops when setting the while condition to always be true, such that the code loops during the entire program execution. In this example, we will calibrate the value of an analog sensor. A photoresistor's analog value will be used to fade an LED. To ensure the appropriate minimum and maximum values of the photoresistor are appropriately defined, the calibration routine, which is initiated by a button press, will be used to configure these values. You will need a breadboard, hookup wire, one digital push button or switch, one photocell or analog sensor, two 10 kilo ohm resistors, one 220 ohm resistor, and an MSP-EXP430G2 launchpad with Energia. Before exploring the code, you will need to set up the hardware according to the schematic and breadboard simulation displayed. Connect your analog sensor, in this case a light sensor, on analog input A3 with a 10 kilo ohm resistor to ground. Connect your button to digital pin 6, again with a 10 kilo ohm resistor to ground. Connect your LED to digital pin 14 with a 220 ohm resistor in series. Ensure the LED's cathode pin is connected to ground. Once you have completely set up the hardware, plug the launchpad into your computer through USB. Let's open up Energia. We will import an existing code example by going to File, Examples, Control, While Statement Conditional. At the beginning of the program, we declare the pin numbers for the sensor, button, and LEDs we are using. We then declare the sensor values that are subject to change while the code is running. In the setup function, we declare the pin mode of the LEDs as outputs and the switch pin as an input. In the loop function, we start by waiting for the user to press the button to activate the calibration routine. In the calibration routine, we turn the onboard LED on to indicate a calibration is taking place. We read the analog input value of the analog sensor. Depending on the value of the sensor value, we will define the minimum or maximum sensor value. After the calibration routine, we return to the loop function to turn off the onboard LED, indicating the calibration routine has ended. We then read the input value of the analog sensor. We apply the calibrated values to the sensor's reading using the map function. In case the sensor value is outside the range seen during the calibration, we limit the minimum and maximum allowable values using the constrain function. Lastly, we fade the breadboard LED with the refined sensor value as a PWM signal using the analog write command. And that's it. Once you have programmed the launchpad, press the button and watch as the light intensity of the breadboard LED changes based on the calibrated value of the analog sensor.